Assalamu alaikum students. So welcome back. This will be the last lecture of the first week, and this is unit 1.4, expressions, equations, and their properties. So we'll be talking about what expressions are, and we'll be talking about equations. We'll try to differentiate between expressions and equations, and we'll look at some of the properties, the types of equations, and how to solve some equations, right? So what are expressions? Before I read go into all of this, basically, I'll just give you an example. So if I combine algebra with the numbers 2x minus 4, basically this is an expression, right? Because you don't see any equals to sign. If I add an equals to sign and I say 2x minus 4 is, let's say, equals to 2, now this is an equation, right? So this is the general difference between an expression and an equation. So when we combine numbers and variables in a valid way using operations such as addition, subtraction, multiplication, division, exponentiation, and other operations as yet unlearned, the resulting combination of mathematical symbols is called a mathematical expression, right? So, like I said, 2x minus 4. I am multiplying x with the number 2, and then I'm subtracting the number 4 from it, right? So I'm performing some operations. So this is an expression, right? It doesn't have to be minus or plus. It can even be 2x divided by 4y, for example, right? So this is again also an expression. As long as I'm doing some sort of mathematical operations and there is no equals to sign, this is an expression. And I'm sure you realize this already, but what are variables? Variables are basically something, it's an unknown quantity. We don't know the answer to it. We don't know the value of it. So we denote it with some letter like X usually, right? Or it could be any letter, A, B, C, D, whatever, right? So variables are basically unknowns and they can vary. They can take any number, right? We don't know that. So when I say 2 times X, I don't know what I'm multiplying 2 with. I'm multiplying 2 with an unknown quantity, right? When I know the value of X is, let's suppose, 2, then I can say 2 times 2, which is equals to 4, right? So let's get back to what we were talking about, expressions. So whenever I am, performing some operations and combining variables and numbers, that's when I get an expression. So expressions are general little statements that do not have an equal sign. For example, 2x minus 4, right? Or for example, 2m cubed plus 12n, right? Now, you'll see it's getting exponentiated. This is what it means, power 3. It's getting orders. There are orders, there's addition, there's multiplication, 12 times n, but there is no equals to sign, so this is an expression. Expressions may be stated in terms of one or more variables. This has one variable x, whereas this has two variables m and n, right? So this is what an expression is. Now let's talk about equation. An equation states the equality of two algebraic expressions. So I'll have some expression right here, and I'll have some expression right here. And when I say they're both equal to something, they're both equal to each other, this whole thing is now an equation, right? So for example, if I say 2x minus 1, and on this side I have 3y minus 2, and I say they're equal, right? So this is one algebraic expression, this is another algebraic expression, and if I say they're equal, this is now an equation. This whole thing is now an equation, right? The algebraic expressions may be stated in terms of one or more variables. For example, 3x minus 10 equals to 22 minus 5x. Also, this is again another algebraic expression, 2r minus 5s plus 8t divided by 3 equals to 100, right? So the term variable is used, like I told you, it's because various numbers can be substituted for the letters, right? Now, solution of an equation. What does it mean by the solution of an equation? So solution of an equation, it consists of those numbers which when substituted for the variables make the equation true. What this means, what the statement means is, let's suppose I have 2x equals to 4. Now, if I substitute the value of x as 1, for example, so this would mean 2 times 1. Now this is obviously 2 times 1 is not equals to 4, so I cannot substitute the value of 1 in terms of x. If I'd say the value of x is 2, then I can say 2 times 2 is equals to 4, right? Which is true, right? So x equals to 2 is the solution of this equation. This is what this statement generally means. The numbers or values of the variables which make the equation true, they are referred to as the roots of the equation, right? So in the previous example, x equals to 2, for example, was the solution, or it can also be called as the root of the equation. We say that the roots are the values of the variables which satisfy the equation, right? So for example, if we have this equation, 3x minus 10 equals to 22 minus 5x. Now I'm just going to perform some trial and error. I'm going to put in some numbers and I'll see if the equation balances out or not. So I'm going to substitute the number 0, right? So what do we get? 3 times 0, this becomes 0, right? Minus 10, and 22 minus 5 times 0, which is again 0. This whole term becomes 0, this becomes 0. So what this gives us is minus 10 equals to 22. Now this is obviously minus 10 is not equals to 22. So x equals to 0 is not the solution of the equation, and it is not the roots of the equation, right? Which is untrue. Minus 10 is not equals to 22. The value x equals to 0 is not the root of the equation. However, if I substitute the number 4 in this case, so what do I get? I've solved it right here for you guys, and you can see that 2 equals 2, right? So both of the sides of the equation, they're equal. So resultantly, x equals to 4 is the root of the equation, right? X equals to 4 is the root, or it can also be called as the solution of the equation, right? Now, there are various ways where you can that you have to there are various methods that you have to follow to find out the solution of an equation that I'm sure that you have studied, that you must have studied in your school levels and your college level. So solving an equation, it refers to the process of finding the roots of an equation if they exist. In order to solve equations, we normally must manipulate or rearrange them. The following rules indicate allowable operations. So what we can do, let's suppose I have an equation. I have some short space, but I'll just call it 2x minus 10 equals to 12, right? So real valued expressions which are equal can be added or subtracted from both sides of an equation, right? Now, uh, what do we do? Usually you must have studied in your school or college levels that if I have to take this, if I have, I have to bring all the variables to the left side, or to one side, and keep the numbers to the other side. So I have to take this 10 to the other side. And when I take this 10 to the other side, the sign, it automatically changes. Now that is one way of thinking, that is correct. But the correct analogy is basically we're adding 10 to both sides. We're adding 10 to this side and we're adding 10 to this side as well, right? And plus 10, it cancels with minus 10, and this, it becomes 2x equals to 22. And this is what we get, 2x equals to 22, right? Now, both sides of an equation may be multiplied or divided by any non-zero constant. I'll write this again right here. 2x equals to 22. Now again, you may have studied that you can take this 2 to the other side. It's being multiplied here, so it's going to get divided over here. Of course, that is a short way of remembering things, and it is effective. But the correct procedure is basically we have to follow this rule. Both sides of an equation, they have to be divided or multiplied. So here we'll be dividing both sides by the number 2. This 2 brings us 1x, right? And we'll get 2 ones are 2, and 2 11s are 22. Resultantly, the value of x comes out to be 11, right? So this is how we're supposed to perform some operations on equations to get the value of the solution of the equation, right? We can also, both sides of the equation can also be multiplied by a quantity which involves variables. Like for example, if I were to say, something like 2x minus 10, again I'll write it as 12, right? So I can multiply both sides by the variable x as well, right? I can do that as well. It doesn't have to be necessarily just constant numbers. Now both sides of a number, they may also be squared. Now both sides of an equation, I'm sorry, they may also be squared. So what I can do, for example, if I have something like 2x minus 10 equals to 12, I can square both sides as well. As long as I'm doing any operations to both sides of an equation, it's valid, right? The equation has to be balanced. Now, both sides of an equation may be divided by an expression as well, which is not equals to 0. So these are some of the properties of the equation, some of the methods that you must have read about in your school levels. And this is just a, a normal review of all those rules for manipulating the equations, right? Next up, we'll talk about some of the types of equations. So basically, there are three types. The first type is an identity. What is an identity? Identity is an equation which is true for all the values of the variables. For example, right here, I have on the left side 6x plus 12, and on the other side, I have 12x plus 24 divided by 2. Now we'll notice that in such types of equation, any value assigned to the variables will make both sides of the equation equal. If I were to assign the value of x to be 1, right? So I'll have to put the value of x1 over here, and of course 1 over here as well. So I'll get 6 times 1 is 6, plus 12 is 18. And right here what I'll get, 12 plus 24, 36. 36 divided by 2 is 18 again. So the x equals to 1 is the solution of this equation. Let's put x equals to 2 over here. Of course, 2 over here as well. 6 times 2 is 12. 12 plus 12 is 24. This becomes 12 times 2 is 24. 24 plus 24 is 48. 48 divided by 2, I get 24 again. So x equals to 2 is also a solution to this equation. Now, it doesn't matter if you put 1 or 2. We can put any value in this equation, and both of the sides of the equation, they will be balanced. So these types of equation, they're called identity, right? The second type is conditional equation, the one that we're more, that we see more commonly in everyday. So this equation is true for only a limited number of values of the variable. For example, x plus 1 equals to 4. Now here, when x is 3, only then this equation is true, right? 3 plus 1 equals 4. You cannot say the value of x equals to 2 is the solution, because 2 plus 1 is 3, and 3 is not equals to 4, right? So this is what conditional equations are. And the next up is a false statement, where basically there is no solution to the equation. A false statement or a contradiction is an equation that is never true. There are no values of the variables that make the equation true. For example, if this is the is equation, there are no values that if you put into this, then the equation is true. If you put 1, then 1 equals to 2 plus 1, 1 equals to 3, 1 is not equals to 3, right? So this is a false statement. And we indicate the false statements. We indicate that the two sides are not equal by using this symbol. This equals to sign and a cut on top of it. This means not equals to. So this means x is not equals to 2 plus x, right? So this was just a general introduction to equations and expressions. In the next lectures, you will see how to solve these equations. You will see even more types of equation. You will find out there are more categories: first degrees, second degrees, right? So you will be able to see and learn and understand how you're supposed to solve all those equations. So this was just a general introduction to your equations, some of the rules that you can use to manipulate the equations in order to find your solution, and an introduction about expressions and what expressions are. So this concludes the your first week, and I'll see you in the lectures for the second week.